Well, hi, good morning, and welcome to my shop for another round with this radio. And today is going to be about the AVC voltage in the radio. Does it exist? Is it getting to where it needs to go? How come the eye doesn't respond at all to variations in tuned signals? So that's what I'm going to be up to. And I think the first thing we got to do is I got to clean my bench. Oh my gosh, look at that pile of stuff there. And then we'll take a look at the schematic. Okay, so here's the schematic, and the area we're interested in is out here in this area here. We see a diode in the tube here. Let me zoom in a little bit on this. A little more. Okay, so we can see a diode there and another diode there. They're at either end of the output here, so that's like a full wave rectification going on in here. So the output here's a ground to the chassis, a small capacitor. This is probably trying to drain the RF out of here, or provide an RF ground at the bottom of this coil. What's going on over here then? This is on the other side of the capacitor. So we're coming down here through a resistor. On the other side is the 35,000, it looks like. On the other side is a bit of a higher impedance, high enough that they shielded the wire here. And where is it going? All the way to the volume control, probably. Oh, it's going all the way to the switch here. Of course, on the diagram it looks like it's going 20 miles, but in the radio it might be quite short. Switch section, rear, front. Antenna switch section. Oh, this is complicated here too. Look at all these capacitors in here. Oy, 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 oy. So it's pretty certain to come back out on the other shielded wire and work its way up to the volume control. So we're at the top of the volume control, and we've come, let's follow this again, straight out, just a wire, okay, big resistor. So on this side, the volume control is in a high impedance arrangement here, 35,000 ohms worth. That's not as big as what I expect here. So you go a little further along. Look at this guy, 4.7 megohms. So when you get on the other side of him, it's even a higher impedance circuit. And what that means is if you put your test equipment on this line, you're liable to disturb the radio tremendously, which is why I'm concerned about where the high impedance is. You might be able to put a test instrument on this line, but it might affect the resonance of this coil. I have a lot more to say about this. You know what? Oh man, I fixed too many radios. I've got a different radio in my head. I'm looking at the schematic going, well, this isn't the way the radio's made. How? Starting right here with these two diodes, and the whole time I'm talking, I'm thinking, this isn't the way this radio is. What am I doing? What I'm doing is I got too many radios in my head. This is definitely the 981. Okay, so everything I said was quite valid though, even though it was causing a cognitive dissonance in my brain. So again, so we could hook up here, but it might disturb the resonance of this part of the circuit. 120 picofarads here. So we could come down here. This isn't a huge resistor, 35K. And we could go on the top of the volume control, which is a typical spot for picking off an AVC voltage. And it would work here. So the DC continues down through here and it meets the ground there. Blocked by this capacitor, 0.006. I'm likely to have changed this one. AVC voltage developing here, full wave, passed through here, the DC passed through here into high impedance circuit. DC passed down this way. And what was this switch all about? Why? Oh, this has to be the phono. When you flip it all the way to phono, then this black wire probably goes right to the phono plug. Sure, that's all this is. So normally this switch is closed here when you're listening to the radio, and the DC just comes along to the top. Now, how big is this resistor? R3 volume control, 1 meg, tap at 360. So it's a meg ohm here. So we've got 35,000 here, dividing the voltage coming out here, the signal too, against a million. So 35 out of 1,000 is 3.5 out of 100, 3%. So about 3 or 4% of the signal is dropping here. The remainder, 96%, is across here. Likewise, 96% of the DC voltage would be sitting here. That's our spot. We'll clip on here and start measuring the AVC there. Yeah, well, the whole time I was preparing myself for a different radio in my head. Earlier today when I was eating breakfast and just thinking about this a little bit. What a schmozzle. Okay, that's all there is to it. Top of the volume control, just like all radios. You know, it even went through my head that the volume control is hooked up to the antenna. That's how stuck I am in the last radio I was working on, which is coming back. Okay, enough looking at that. Let's find this spot. And you know what? This is the easiest can be because it's up above. And it's just really easy. And I probably did this already. I'm probably going over the same territory again, but that's okay. So change a couple capacitors back here. I do remember the original one here, still here, was shielded very carefully, and the ones I put in are not shielded. This guy being the unshielded one. So that may be presenting a bit of a hummy problem. Now, there's an in and an out, where there's one side. So here's a terminal here. Small terminal strip. Make the connection between this resistor and the capacitor. Resistor coming off of one terminal here. The other terminal is a bare wire going right to the chassis. Okay, so that answers the question. The one that's going right to the chassis is the wait a minute. 1, 2, 3. Yeah, this is the tap. So this is actually the one I'm after. This is the input side here. This guy. Isn't he supposed to be shielded? There's some shielded wire involved here. Yeah, the shielded wire actually is starting right there. So this is leading to a shielded wire. And this has come from the capacitor that I replaced with the unshielded one. So I've introduced unshielded lead, this length here, up on top. It's probably where a bit of hum is coming from. So we're going to hook up here. As well. We'll just use an indicating voltmeter to track this voltage. Just a little overlit, isn't it? Pick it off this way. There we go. DC minus, and we'll put this at 50 volts to start. And what we should do is get a notion as to what the voltage range should be on the AVC at the tubes. So we'll pick one. 6SA7. Is that the first tube? Let me just look at the schematic here on my own briefly. Just give me 1 second here. So 6SK7, 6SA7. So the 6SK7, is it controlled with, I'm just checking to see if it's controlled. Yes, it is. So the first two is controlled, 6SK7. So we'll look in the book for 6SK7. We'll ask ourselves, what kind of range of voltage does it need on the grid to operate, to do the automatic volume control type thing here. Grid number 1. No, that's not the heat maximum ratings. No, typical operate characteristics. Grid number 1 voltage. -1 or -3. So almost, wow. And then I don't think this is going to give a range. Oh, grid number 1 voltage for transconductance of 10 micromoles. So -35. So I think that's kind of the cutoff amount they're giving you there. So if you put -35 on the grid of this tube, you're getting into the cutoff range. I think that's what they're trying to say. -35. So you would expect an AVC voltage to range as high as perhaps that, 35. That's a dandy voltage. Would it really be there? Control grid bias variation will be found effective in changing the volume of the receiver. In order to obtain adequate volume control, an available grid bias voltage of approximately 50 volts will be required. What? An available grid bias voltage of approximately 50 volts will be required. The exact value will depend upon the circuit design operating conditions. This voltage may be obtained, depending upon the receiver requirements, from a potentiometer across a fixed supply voltage, from a variable cathode bias resistor, or from an AVC system, or from any combination of these methods. Okay, so 50, up to 50 volts. So, okay, that's enough. That gives us an idea. We're not looking for a couple volts here. We're looking for a large voltage. I'm looking on the volume control. We already know that about 85% of the available voltage will show up there. So what I read here is going to be reflective of what is actually on the grids. The tubes, I think. So we're all set. We're all set here. Volume's down. Everything's normal. We got we have an antenna for an antenna. We're certainly going to want to be fooling around with a known signal here, so I'm going to switch to the signal generator. Anything happen over here? So I left it tuned to a station and I can hear it. I think if you spend years and years listening to hissy radios like this, you start developing really good hearing. Okay, let's watch this meter. I'll put this right where there is some voltage there. 15 volts full scale. Yeah, it's working. Wow. Good radio. So I think that's 1010. Wait a minute. We're on the shortwave band. Give it the full juice. This goes a little higher now. A lot more volume. Come on, let's keep going on the shortwave band here. Well, it certainly is responding. Oop, oop, oop. 50 volt scale. Look at that. So, I mean, we're getting a pretty good voltage there. 15, 20 volts on a weak signal. Okay. Very good. Very good. So this leaves the question, why isn't the eye responding to it? So I'm now going to put on the signal generator here. It's a very low output. And we still have that antenna capacitor to consider too. I'm bypassing the apparently weak antenna capacitor, firing the signal right into the radio. We can continue on the shortwave band here. Let's see how accurate the radio is. So we'll put this 1185. 1185. And we'll dial up 1185. No way home. Make sure we got it connected. Yes. Volume up. No, the problem was we didn't have any volume on the radio. Just down a little bit. Okay, we'll put this on 11. That's 11,800. Oh, whoops. There we are. 11,800. We'll find it on the dial here. A mile out. Oh, I don't have the base plate on. No base plate on this radio, so no alignment actions taken, Jim. Okay, so now I'm looking at the magic eye in there, which is going to be very hard to get on camera properly. Let me just try something here. Dump more light in the room, and the camera will cut back a little bit. You can see you can see the wedge at the bottom of the eye, though. You can see it. So let's go ahead. Okay, so now we're going to get some notion as to how strong that signal is on the antenna. First, I need to calibrate this guy properly. So to do that, we go here. It's calibrated. This meter's right on. This is up full. This is the adjustment. 10, right on. What did I do with it? Turn the radio down. That's what happened. So we can read this pretty directly. So it's 10 times 100. So it's 1,000 microvolts. 1,000 microvolts coming out of here, going through this impedance matching box, really what it is, reaching the antenna. So typically a really good radio is going to work with 3 or 4 microvolts, but you could have more noise than that, so a little tricky. I mean, in a test environment you can do that, but off an antenna it's not a very helpful thing to know. So what's the deal? So we got 1,000. Think again. 1,000 microvolts. It's not really that bad. I mean, I barely got any volume on the radio here. But the eye's not closing very much. So the question would be, is this signal strong enough that the eye should close? I don't know. I'm goofing around. I don't think so. I would think you could get a signal 10 times this strong. Like that. It's interesting to keep your eye on the AVC thing. Can we keep our eye on everything? Reduce the light here. So I'm going to snap down by a factor of 10 the signal coming in. The interesting thing, if you listen, it sounds almost the same volume, which means the AVC seems to be working quite well. Let's go down another 10. I can still hear it. So now I'm supplying 10 times 10, 100 microvolts to the antenna. You can still hear it quite nicely. Go down another 10. I'm now supplying 10 microvolts. You can still hear it. Let me tune the radio just a little bit. Well, based on that sort of empirical approach, it seems to be working quite fine. I can go right down to Well, there's something fishy going on here. I went down another 10 and nothing changed. So, well, actually, the AVC meter is moving up and down. Okay, we're going to go up. We're starting with 10 microvolts on the antenna, supposedly. No, this was 1. That's 1 microvolt. 10, 100, 1,000. It's trying to see the AVC operation on that meter. I'm going to go up to 10,000. So this is about as strong a signal as you're ever going to get on an antenna, I think. You can see the eye is not closed all the way. I know it's a little hard to see there, but the expectation is the eye would close all the way. So either the output of the IF is not what it should be. There's a weakness. Could be a weak amplifier tube in the front end of the radio. Could be a misalignment of the IF, which I don't think it can be. Could be circuit problems with the feed to the grid of this tube. Could be a resistor in there or something like that. And probably 2 or 3 more things it could be that haven't come to my mind. So I think the one I want to check is components that are involved in delivering the voltage to the grid of this tube. Okay, leave this turned up just a little bit so I can't forget it's there. And we'll take a look at the schematic again here. Okay, so we're looking at the I tube way over here. There's the grid, and we follow the grid wire back. Did I lose it? So it's connected just past the I'm sure this is 4.7 meg resistor. So it's getting the same voltage, if you like, that all these grids are getting. It's being treated no differently than all these other tubes. There's no resistor. It's basically nothing but a grid sitting here. So the action of this tube is controlled by this resistor. And if you put a bigger resistor in here, the tube's action becomes more sensitive, I think. So like if we put a 1.5 here, the eye might close. I think. Not worth doing. What I'm interested in finding out is there something wrong in the radio, especially, not so much the eye, it's these tubes I'm a little more worried about. Are they getting the AVC the way they should? They certainly appear to be. Certainly from watching the meter, listening to the radio respond, feeding in a signal that's ranging 10,000. And the voltage coming up right now, the voltage sitting on there is almost 30 volts. Is that right? No, wait, I'm reading it wrong. No, it's only about 8 or 9 volts. It's not very much, really. But in the manual, it said the amount of voltage you need on those grids to make them to change the mutual conductance of the tube, or its gain, can be as much as 50, or you need to have 50 ready. It doesn't have to be 50, depending upon how the circuit is designed. Well, it seems like insufficient AVC voltage variation. You know where I'm going to go with that? I think I'm going to test the critical tubes here in the string that develops the IF voltage, and that'd be this guy, and this guy, and this guy. Now, did I test all these tubes already? I think I did, didn't I? Did I? Sure. I'm sure I did. Well, we're going to do them again, very carefully. Just, we don't even have to do this one, really. It's really these three. 2 of them are the same tube, 6SK7. Okay, I think that's the next smartest step for me here. A closer look at the tubes here. I was thinking the other day that rather than take a tube out of the radio and put it in a tube tester and measure it in the tube tester, if I had a known good tube based on a tube tester test, in a radio like this, I could simply pull out the existing tube, put in the known good one, and see if it works better. That's a whole different approach I could take here. But I'm not gonna. I'm gonna put those tubes. I'm gonna put those three tubes. Wait a minute. Get out of there. Three tubes through a couple different tube testers. That should be some fun. Hey, that'll be my day. Okay, here we go. I got a record sheet here to keep notes from the tests on 1, 2, and 3 tube testers here. I'm going to put this tube through, and then we'll compare the results after I'm done. We'll see what's up. Just so you know, the first one here, the first tube tester here is a Jackson 648A. It says dynamic tube tester, but my understanding is that this is a emissions tester, basically on steroids. Then I've got the Weston 981. 981. That's the same number on the radio I'm working on. That's a funny coincidence. So this is a dynamic tester. We'll measure the mutual conductance or transconductance of the tube. So this would be considered a bit of a better tester than the other. All three of these I'm showing you are well-respected tube testers. So this is a well-known one here in Canada anyway, Stark 966. It's actually based on the Hickok circuit for measuring, once again, measuring the mutual conductance. Mutual conductance tube tester, dynamic tube tester. These are all set and ready to go. I put the first tube through. Might as well leave the video running. Watch this exciting thing. First, double check the settings. 6SK7, 6.3 filament voltage, A1246, A1246, A358, A358, 15 here. That's it. Stick it in. Switch on. So this is the only tester I've got where the meter, when you're not actually doing a test, is upscale. It's in the middle here. This thing just always is reflecting the line voltage until you push the test buttons. And the line voltage is set properly here. Okay, like I think all tube testers, there's a shorts test. I can't expect these tubes to be terrible because the radio works. Okay, so now there's a single test here. We push WY. Okay, now this has a life test. If I push this switch, it'll reduce the filament voltage by about 10%. And the idea is that gives you some notion as to how strong the tube is. So you can see it's quite dependent on the heater voltage. So I would qualify this tube on this tube tester as still okay. 100% is there. And this is coming up at 80%, so I'm going to record that number, 80%. Okay, move on to the next tube tester. And before I make a big mistake here, I'm going to record that. 80%. 80% on the RF tube. Okay, so a quick check here. 6SK7, 6.3. 6.3. 2 on the signal level. 10L for bias. And then 17251. 17251. And 4630. 4630. Good. All set. Pop them in. Give it a moment to warm up. See if I can get the scale to show up on the camera here. Okay, right like that. That's not bad. Okay, first we do the short test. This time we're watching the meter. I didn't mention the last one we were watching a little light. This one we'll watch the meter. That's normal. Very good. We're ready for the test. 6SK7. So the rejection point is 1520. So 1520 is actually straight up. So it's got to be over here. 20. Okay, here we go. So, you know, I make that out to be like 1530. It's just a hair above the reject point. So we're going to have to record this fairly carefully. 16. So it's 16 instead of 1520. So it's just barely passing. 15. 6. So number down. 1520 is the rejection point, and the actual reading was 1600. So it's if you were to do that in a percentage, you would say it's like at 15% of its remaining life, at very low, according to this guy. Okay, so that's two of them kind of saying this tube could be weak. If you put it in radio, I'll come over here in the dark. Turn on, we'll double check first. 6SK7. 6.3, can I see? 6.3 is the filament. JR. These are the filament switches, if you like. Once you have these set, you can pop a tube in. As long as you have the voltage set and these set, you can pop a tube in. It warms up while you do the rest of the settings. 4765. 4765 with a 3 at the end. Yep. Make sure you're looking at the right one here. 4765. 22 on the bias, correct. 72, it's pretty dark in here for me. 72 here, yep. Press P4, reject point is 1200, good tube at 1900. Okay, now this one's back to having a neon bulb to indicate shorts. The flash is fine. In fact, the flash indicates a tube that's operating. Okay, no shorts in it. P4 is the test button. 6SK7. P4. Okay, now can we see the meter? Oh, you can see it quite clearly. So we're doing this with the scale set on 3000 to start with. So you make a direct measurement. And we should see, right, 1200 and 1900 are the two ranges. So 1200 on the 3000 scale. So it's got to get basically out of this red zone here. Not that the red thing means anything right now. It's got to get up past where my finger is. Before. Right where my finger is. So we've had three to this one's actually, now I'm going to flip this over to English. Now we can read these words. Replace and good. It's actually at the top of the replace. So the three testers tell me now that this tube is a little weak. Okay. Three testers telling me the tube is a little weak. So that, you know, that could be it right there. It's at the bottom of its capability. The Weston tested. Look, I wrote it in the wrong spot. 1600. 1520. And on the Stark, we tested it at, so I'm going to get off, just doing it again here very quickly. The actual number would be, you know, this is a falling test too. It's another indication of an old tube. So we're at 1000, 11, 12, 1250, and it's supposed to be, yeah, see, almost the same, eh? 1250 reject point,
and the actual reading is 1300. So these are extremely similar in terms of it's almost shot. Jackson's saying it's at 80%. And this is not supposed to be here. That's interesting. Now we're going to put that tube back in the radio where it came from so we don't mix things up. Going to get the other 6SK7. Uh-oh. There it is right there, stamped right on that. And then bring there 6SK7. Okay, that's good. Here we go, another round. Put this one in. So on this tester you can get an idea of the degree of leak or short that's in your radio, or in your tube rather. When you do the tube test, if the light comes on, you can then turn this control back. See, it's set right now to the top at 2 megohms. You turn this control back. When the light goes out, you can read this, and it'll give you some notion of how much of a leak it is in the tube. Some notion anyway. 2 megs all the way down. Well, that says 25 megs. 0.25. That says 0.25 megs. So it's 2 here, just goes down. Okay, that's enough beating around the bush while the tube warms up. What does it do? No shorts. Okay, and we do the test. The test for this tube is WY. Oh my gosh, it hardly moved the meter. It's into the bad. So we've got both of these are coming out bad. Okay, so let me do the age test here. The other testers to do this too. See it drop now? So you have 2 weak tubes here that I've had in the radio. So this is basically on the line. It's bad. This is testing bad. What's the percentage? I want to get the percentage. WY. Actual percentage is 60%. Must be 60% of the expected flow. I think you can read it that way. 60%. And at that point, bad starts at 70. So this is the first one tested good, sort of. Next one tests bad. Bad. Okay, on to the next tester. Hey, you ready for another tube, Mr. Tester? Okay, I've got no little ditty to tell you while we're waiting for the tube to warm up. So go ahead on the short test here. Now, doing a short test, sometimes it's recommended that you flick the tube while you're doing it because the elements can be loose. Maybe at the moment you're doing the test, the elements are not shorted, but they will be later. But I don't do that. I just don't do that. Shame on me. Okay, so we're ready to do the tube test. Just to remind ourselves, 6SK7, 1520, right, just past the halfway point. Not making it. So in this one, it's reading 1200, and the reject point is 1200, and the reject point is 1520. It's a reject. It's a reject back in the day where radio repair guys were selling tubes. Today, when tubes are becoming scarce and expensive, a weak tube is not necessarily a reject. Anywhere you use it, you're going to get a weak result. But let's just say I don't throw away tubes that are weak. I just make a record. Put it in my collection. I serialize these tubes. I put a number on them. Put them in my collection. I keep a record by serial number. Okay, ready on the shorts test here. I use this light. no short. P4, and just reminding myself, 6 SK7, 1200 and 1900. Okay, so we're on the 3000 scale. Again, 1200 right here. Gotta get past there. And going down. Okay, we'll flip this onto the English. What does it say in English? It says, replace this tube. Okay, so, two of the, these are the two very important tubes in the radio. All tubes are important, of course, but these two have a lot to do with the gain, especially this one. This one is the IF amplifier, and I think that's the one that we really count on producing gain through the IF, which would explain a weak, let's put this like this, it would explain weakness. like my explanation here. I didn't record the number from the last test, I just want to get it. 6SK7. It was up around here. That would be about, say, 1300 on there. Well, it's the same as the last test. Wait a sec. Where are the horses here? Do this correctly. I'm going to put this back in the tester. And we'll get ready for the next tube. Ready for the next tube. So the next tube, the only other tube I really want to do in this lineup. So we've done this one. I'm going to do this one next. This is the 6SA7 mixer tube. My understanding is you don't expect too much gain out of these, but obviously if they're not working right, they're not going to give a very good result. Okay, back to the 6SK7. It's back over here where I forgot to take a reading. 3000 scale. Reading is 1000. 1000 on the 3000 scale. And it should have been 1250. Well, okay, so I want this radio to work well. I think I got to change those two tubes. Now I got to set these testers up for the 6SA7, so I will go ahead and do that. Okay, I think we're ready to go now. The 6SA7 is two tubes, kind of. So most of these testers are going to want to run 2 tests on it. This one, yeah, has 2 tests. So the first test, I don't know what I'm testing. There's an oscillator section and just a RF amplifier section in there. Probably, I don't know, probably the amplifier first. 35. Double check. A12678. A12678. And AC345. AC345. Very good. Okay, tube should be warmed up. Looking for shorts on the light here. Okay. And we're testing with WY. Oh, look at it drop off. Well, it's a third tube in the front end of this radio is showing up weak here. So as a percentage, that's about 60. It looks like it's going to drop to maybe 65 on there. So I'm going to write 65%. 65%. And the next test. So on this tester, they've made it so you don't normally, well, you have to. I was going to say you don't normally have to pop out the top row, but you do here. Pop them out, and then pop them back in. 1, 2, 8. That'll start the heater going again. A56. A56. 30. And the test is V. Let's go through this guy just in case. Nope. 30 V. V. In the good but dropping. And not too far in the good. Okay, you get another chance to. You're not completely. Oh, yeah. Okay, here I'll do this. Double check now. 6 SA7. Who's here? Somebody here? Who's that? Who's here? Shadow. Coming in? Come on in. Never mind that. Come on. Come on in. Come on. You're welcome. Come on in. That's good. You know where she wants to go? She wants to go into the laundry room here. In you go. There she goes. Okay, you can stay in there for a while. The reason she wants to go in there is because the back window is great to sit in. Oh! What's going on here? I got more than I guess I left the other 6 SK7 in the tube tester all that time. Okay. Now I totally lost track of everything I was doing, which is par for the course. SA7. You know what? Did I don't think I lost control. The cat threw me off totally. Okay, 1100. 6SA whole tube. 1100. Okay, so it's well over 1100 on here. 1100 would be there. This is 15, 16. 16. I got this right. 16. Yeah, 1100. So this guy's saying this tube's pretty good. 16 is what it measures. 1100 is the rejection point. Let me write it down here. 1100. That's one part of the tube. Now the other part of the tube. No, this just does one test for the whole tube. It says right on it. Whole tube. Okay. On to the. Oh my gosh! What happened? On to the next guy. What happened there? Hold still. In you go. Oh, double check. JR. Yeah. Okay, and going a little quick here. 6 SA7. 2 tests for this. First test. JR 7346. 7346. 5, 21, 34, press B4. Should be between 470 and 750. So if we look up here now, 470, see it's way down here. Between 470 and 750. So in this area, surprisingly low for a tube tester. You usually like when a tube tests good, they like the test to be up higher. But this is actually measuring its mutual conductance, so it is what it is. Hit the button. So it's right in that range. So it's measuring 500 now and falling. 500, and I think did I say 470? There's a cat trying to get out of the laundry room here. Did I say 470? You want to come out? Come on. Never mind all those interesting things along the way. Cats love to. Okay, gotta close this door. So you're either in here or you're in there. Where are you? You're in here. Okay. Now, you ever wonder why I get things wrong? Distraction City. Right, around 600 and dropping a bit.
coming out at 500. And I was just looking to see what the number was. 470, so it's like right on the edge.
So okay, all testers are basically saying this tube's right on the edge. There's 3 bad tubes in the front end of this radio. 3. Just a second, I gotta make some notes. 470, and the actual number was 500. $470 and 500. There's a second test to do. Out here. Okay. Second test. Put the tube out when I change these numbers. 3, I don't think I have to. 3, 5, 4, 6. What are you doing there, cat? 3, 5, 4, 6. 3, 5, 4, 6. With the 7, 21. That's the same. 34. That's the same. B4. Same thing. Okay, other section of the tube. We'll do a shorts test here. No flashing. No tube. Okay, come on, Shadow. You want to go out? Where's your chance? Go out? Stay in. Stay in. Okay, she's staying. She's really excited about the tube testing thing. She's trying to figure out which tester to jump on. She got one. Yeah, come on up and join us with the testing here, Kat. B4 on the second section. Ooh, what have I done? Something wrong there. That's one of the few times I've seen the fuse light come on, which usually means I've done something wrong. What have I done? You know what I did? What did I do? Okay, without making any changes, JR 5346. JR 35. Duh. Okay, 53. This is one unit you can certainly change these numbers. 46 and the 7. Look at this right now. 53. 53. Oh my gosh, how did I get that wrong? I got that wrong twice. Why did I? It's the cat's fault. You cat. Yeah, you. You're the one. You're in here causing trouble. That's you. Try this again. A little cold, a little wet outside today. Just distracted daylights out of myself here. Well, I really shouldn't be. So P4 is coming up 5, 6, 700. And 470 is the reject. 700. 470. Well, I think, you know, really. What do you think of that, Shadow? I think it's pretty clear here. I've got 3 weak tubes in the front end of this radio. I got to resolve that. So I have many. I have many of these 6SK7s, 6SA7, all that kind of stuff. I'm going to go hunt down a couple or 3 good tubes, and I've already tested them. I have test records I can go by, so I can just pick 3 tubes, put them in here. We'll see what happens. What do you say about that, Shadow? Look in the camera. Very good. Good cat. Look at her. Don't stare at me like that. So unnerving. Okay, that's what we'll do. I'm going to hunt down those tubes and stick them in the radio. Okay, I got 3 excellent replacement tubes for the radio. So I'm going to pull out the bad guys. Set them over here. The SA, double check, 6SA7. I've been very lucky with my tube collecting and really not done any great effort at it. And yet somehow I've ended up with a large number of exactly the kind of tubes that I need to do this kind of stuff. There we are. She's charged up now with new tubes. Wow, exciting moment. Has it really done any good? So we have the antenna, outdoor antenna hooked up. We still have the AVC meter hooked up. Just get that out of the way. Okay, tubes in. So I picked the best tubes I had in my collection. Okay, dim light. Very good. So we're on the signal generator, but the signal generator is switched off. Let's just go on an antenna while we let the signal generator warm up here. So it's all about the eye. The eye will tell us. The eye, when things are working properly in a radio with a magic eye like this, the magic eye becomes a instrument because it really is just telling you the AVC voltage. It's a little hard to see, but you kind of see the pi at the bottom there. And here we go. We're on the 11 megacycle. Oh, and that's the signal generator right there. 11,799. Oh my gosh. So again, the bottom plate's missing, so maybe that's why this is way off. It should really be here. Not very reassuring. Let's go for another band here. Okay, so the volume setting is very low, so that's a good sign. Another band. Well, let's try it. So you probably didn't see this, but because you can't. The eye. So when the radio's going up and down on its own here, the eye is moving. What's happening here? Wiggling a tube in its socket. I don't know. Okay, whatever it was. It's not the right. I think that's Cuba. Very, very small eye movement. Okay, that doesn't prove anything yet. Let's try this 9 megahertz band. And lots of volume. Louder at one end than the other. I don't think that's a good sign. Down. General shortwave band. Ew. These are strong signals. The eye is hardly moving here. Almost no movement. Now, what's happening on the voltage here?
Interpretando una hermosa canción, la canción cristiana titulada Marinero.
15-volt scale, almost nothing.
¿Qué les parece? Y hoy también recordamos el lenguaje de los marineros.
Sounds good.
En el habla.
Okay, I'm tuning some more. Okay, this is the stupidly strong station at 9.333.
Baptismal formula.
Oh my gosh.
They say where we're going.
So the fact that the radio got a lot louder is another indication that AVC is not really working properly here. So I can see the eye back there. You probably can't. It's just changing slightly. And if any signal is going to close that eye, it'll be this one. In the meantime,
Because we just need
sounds
to
pretty
examine
good.
one of Eusebius's post-Nicene writings. I want you to bring
Hard to tune with a thin shaft.
the land. To exist, the Father truly Father, the Son, and the Holy Ghost truly Holy Ghost, as also our Lord said, sending forth His disciples for the preaching.
So unfortunately, this strong station is off the band here.
Baptizing them in the name of the Father and of the Son and of the Holy Spirit. Can you believe that?
You know, it really shouldn't be, should it? Not there. Wow, broadcast band is the last one to try out. There's some movement in the eye with this very strong noise signal, which you can't even hear. That warbly thing.
And it's coming. Call Dr. Wu. Or help. 1-800.
Okay. So I think there's more wrong in here. Still doesn't seem to be operating right. Some of these noise signals on the broadcast band are ridiculously powerful compared to radio stations, and they should close this eye. They should close it right past itself. Not much happening with it. So something's going on still. The radio itself seems to be performing correctly, or no, because the volume change as you go from no station to some station is gigantic in the case of that powerful station. And the AVC should have knocked that way down. AVC voltage is varying, but the scale I've got it on here, 15 volt scale, and it's only getting up around 6-7 volts, which in many radios is okay, but I have the feeling in this one it's supposed to go quite a bit higher yet. Can't be the tubes, I've changed them, except for the, you know, there's one more tube in here that could be causing a problem. And that would be the detector tube. Okay, we got to give it a test. We must give it a test. The detector tube is probably plenty hot. It's definitely warm in there. Sham, wow. How about a tube with no number on it here? Oops, here's the camera. Q7, I believe is what this says. Q7? Okay, I'm going to take a peek at the schematic here. Just bear with me a moment. 6SQ7. Well, this has to be a 6SQ7. Oh yeah, I just can't see. 6SQ7. Okay, we're going to give this guy a test. We'll test him with this guy. 6SQ7. 6SQ7. 6.3, signal level 1, 18L.
bias 25100, 25100, 3760, 3760, 37. 37 on the sensitivity. F for the plate. Make sure that's correct for sure. Okay, reject point is 760. Let's pop it in. So for this tube to be bad, for the diodes to be bad in this tube, I think what has to happen is the cathode has to be worn out. I think that, and then the whole tube would test bad, I would think. Okay, shorts, watching the meter. Nope. The GM tests, what did I say it should be? 760, which is right there. Way above, way above. Okay, next test. So that was the triode. Now we're going to test the diodes. It's the diodes that will be bad, but surely if the triode tests good, the diodes will too, won't they? This tester, I have to pull the tube out, I think. 2013P. 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 0760 0760. Sensitivity 48. A for the plate switch. P1, P2 does two tests, P1 and P2. And we push the diode check. And all it's got to do is get above this line here where it says diode's okay, that you probably cannot see. Back in. Like I say, I think if the triode tests good, the diodes will test good too, because essentially you've tested the cathode. Let's just double check this while we're waiting. Bias doesn't matter. Signal level doesn't matter. Very good. Okay, shorts, just in case something funny going on. No shorts showing up. Diodes and rectifiers. Diodes okay, just above my finger there. She's a winner. Okay, so there's nothing wrong with this too. Okay, so that really pretty much is pretty conclusive that the tubes in this radio now cannot be responsible for any weakness found anywhere. So the weakness has to be from somewhere else. And I think I'm probably going to be measuring some resistors shortly. So, but that's it for today. That's good enough. Slowly progressing here. Thanks a lot for watching. See you tomorrow.